Okay, guys, please go back to your notes so we can continue our examples. Okay, so I want this video to focus on the idea of factorization, and we will target these 5 different categories of factorization. So let's begin with the idea of group factorization. So for example A, you have 6x squared minus 2x plus 15x minus 5. So right now we are under the umbrella of group factorization. And a lot of times when you have group factorization, you have 4 pieces, right? 1, 2, 3, 4. 4 pieces. So what you want to do when you have group factoring is look at the first pair and then focus on the second pair. If you look at the first pair, just these two, look at these pieces and ask yourself, what could you take out from these 2 pieces? If you look at these 2 terms, can we agree that what we can take to the front would be 2x? And if you take away 2x from 6x squared, you're left with 3x. If you take away 2x from 2x, you're just left with a 1. Now focus on the second pair, these 2 blocks. What can you take out from these 2 terms? Can you see that you can take out a positive 5? And what would we be left with inside if we were to take out a positive 5? Well, let's see. If you take 5 from 15x, you're left with 3x. If you take 5 from 5, you're left with 1. And a negative because of the negative. Now, the observation, folks, is that the parentheses, right? The parentheses, they match. That's how you know that you're on the right track when you're doing group factorization, when you get to the point where the parentheses match. And because the parentheses match, what you want to do is this. Take this 3x minus 1, that repeating block, and take it out to the outside. Let me just throw some brackets in here. So if you take out 3x minus 1 from this first cluster, you're left with 2x. If you take the 3x minus 1 from this second cluster, you're left with positive 5. And this is our final answer, but maybe we could write this down without the brackets, just use parentheses instead. So final answer, 3x minus 1 times 2x plus 5. Box that in. Let's say you had extra time on a team test. What can you do to your answer to check your answer? You could go like that, like that, like that, like that. Maybe your teacher called it FOIL, but really it's just a distributive property. If you hit this with distributive property, you should get back the original question. But as is, your final answer is right there. This is the factorization of this here. So let's move on to example B under the same umbrella of group factorization. How about this one? 5x squared plus 35x minus 4x minus 28. So let's do this one, and then we'll move on to the next subcategory. So here, focus on the first 2 terms. What can you take out from these first 2 terms? You can take out a 5x, leaving you with x plus 7, right? I could always like test my work along the way, because if I distribute, I get back what's above. All right, now look at the latter 2 terms. What can you take out from those ones? Well, because this sign is negative, I'm going to go ahead and take out a negative. Now, if you compare 4 and 28, you can actually take out 4. So we can take out negative 4. And if you take negative 4 away from these terms, you should be left with x plus 7, right? Because the negative 4 times the 7 is negative 20. Now, look at your work. Do the parentheses match? They sure do. So you can take out x plus 7 to the front, and you'd be left with 5x minus 4 on the inside, and that gives you your final answer. So this is group factorization when you have 4 terms. 1, 2, 3, 4. 4 terms. Let's keep going here. Now, the next one is when you have trinomials. Okay, so trinomial factorization. So let's discuss trinomial factorization. So let's call this example A. So we're resetting. So now this is 6x squared minus 5x minus 4. Okay, so put this on your notes. So now here the difference is that this has 3 pieces instead of 4. The previous problems had 4 pieces, this has 3. So the idea is this: turn 3 pieces into 4 pieces. Once you have 4 pieces, do what you just did twice. So here's what we do. If you want, draw what appears to be a large X. And up here in the top, what I want you to do is I want you to go 6 times negative 4. So you go this times this, and that's negative 24. Now just take this number here and put it in the bottom, negative 5. And I'm sure you've played this game before. So let me just remind you in case you forgot. So on the top, you go this number times this number. In the bottom, you just put this number. Now, I want you to think of 2 numbers there and there. That these 2 numbers, they multiply to give you that, but those same numbers add to give you this. So what are the numbers? 2 numbers that add here, but those numbers multiply there. Or rather, multiply here, Lee, and add there. So watch, let me tell you the numbers, and then you'll see how this works. Negative 8 and positive 3. Do those numbers multiply to give you negative 24? They sure do. Do those numbers add together to give you negative 5? They sure do. So what the heck do you do with these 2 numbers? You use these 2 numbers to tear apart the middle term. Watch, let me get rid of this. Let me get rid of all of this. So we said negative 8 and 3, right? We said negative 8 and 3. So what you do is you go to the original and you go like this. 6x squared, negative 4 is there. But what you do is you take the negative 5 and you break it up with those 2 numbers. Watch. Negative 5x plus 3x. And copy that down while I erase some of this here. Let's get this out of the way. So notice that we have not cheated. This here is still the original negative 5. But the benefit of doing what we did is now you have 4 terms. Now that you have 4 terms, do what you did a moment ago and you'll be done. So focus on the first 2 terms. What could I remove from the first 2 terms? It looks like a 2x, leaving you inside with 3x minus 4, it looks like. Now look at the back 2 terms. It seems like nothing comes out from them, so just take out a 1, a positive 1. And if you take away 1, you're literally left with the same as before. And that's good because the parentheses are a perfect match. And that gives you a final answer of 3x minus 4 times 2x plus 1. Box that in, you're done. So let's do one more of this type, and then we'll move on to the next subcategory. Okay, so that's example A. Now let's try example B. So let's get rid of all of this. Example B goes like this. X squared plus 6x minus 40. This has 3 terms. We're going to break this up into 4 terms and go group factorization. There's no number in the front, just put a 1. All right, do the X thingy. And in the top number, you want to go 1 times negative 40, which is negative 40. Keep the middle number and put it in the bottom. That's just 6. Now find the 2 numbers that they multiply here, but they add there. Think about those 2 numbers, and you'll soon see that the numbers you need are, it looks like positive 10 and negative 4. So let's take positive 10 and negative 4, and that's how we're going to break up the 6 in the middle. Positive 10 and negative 4. Positive 10 and negative 4. And everything else stays the same, right? It's the middle piece that gets broken up into 2 smaller pieces. Now let's go group factorization. In the first 2 pieces, you can take out just an x. and you're left with this. In the back two pieces, you can take out a -4, and you're left with this here. The parentheses are a perfect match, giving you a final answer that goes like this. Okay? Box that in. So these two examples we just did, I think that's like the hardest concepts of this whole video. Now let's move on to some more stuff that's a little less time consuming. So now the next part that I want to focus on, the next subcategory, is on DOS, difference of squares, a difference of squares. So for that, here is a fact. Jot this down. A fact that says that a squared minus b squared is the same as a plus b times a minus b. This is the factorization of something that is built like this. If something looks like a squared minus b squared, it's equal to this. This is how you break it up, right? So let's use this fact and let's do a bunch of examples because these are really fast. So example A, how about x squared minus 144? First of all, is this a difference of squares? Well, difference requires a subtraction. We got that. Is this and this perfect squares? Do you know the square root of x squared? Do you know the square root of 144? If so, then you can quickly factor this down as 1 positive, 1 negative, x and 12. Done. X plus 12, x minus 12. If you're unsure, then go green and expand this, and you'll get back the original expression. Right? Difference of squares. How about this one here? What if we have 9w squared minus 25? This is a difference of squares. 1 positive, 1 negative. What is the square root of 9w squared? 3w. 3w. The square root of 25. Done, 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 done. Let's make this a little more interesting for those of you who want a challenge. How about example C? How about p to the power of 20 minus 100? Is this a perfect square? P to the 20th and 100? I think they are. And there's a difference because this is a minus. So watch. Here's how this goes. 1 plus, 1 minus. Can we all agree that it's going to be 10 and 10 in the back because of the 100? Now, the question is, what's the square root of p to the 20th? It would be p to the power of 10. P to the power of 10. Because just like 10 times 10 is 100, so P10 times P10 is P20. Because P10 times P10, you add the exponents. 10 plus 10 gives you the 20. See that? So this here would be the factorization. Last one of this category, then we'll move on. Example D. Let's go with q to the power of 16 minus 3. I claim to you that this is a difference of squares. Let's open the parentheses, and let's put a plus, and let's put a minus. What is the square root of q16? Well, can we agree that it would be q to the power of 8? Q to the power of 8. Because q8 times q8, you go 8 plus 8 to get 16. Now the question is, what's the square root of 3? Literally, square root of 3. Square root of 3. You see that? This guy times this one, square root of 3 times square root of 3 is just 3. So this technically would be your answer for that difference of squares. You've probably seen all this before, so let's move on to the next category. And instead of difference of squares, this would be DOC, difference of cubes, powers of 3 this time instead of powers of 2. So here is a fact. It goes a cubed minus b cubed equals, it goes a minus b, and this is going to go a squared, and this is going to be plus ab, and this is going to be plus b squared. So these are rules. These are facts that we accept. And this is for a difference of cubes. And this here would be your factorization. So let's do a few examples, and then we'll see where we are. So example A. Let's go with x cubed minus 8. So this is a difference because it's subtraction, and this is a perfect cube, and so is this. So according to our rule, here's what you do. I would fill in all of the symbols. The symbols would always look like this for a difference of cubes, right? It's a minus here, and it's a plus plus, where this is a 2-piece, and this is a 3-piece. So here, what goes in here? Well, what's the cube root of x cubed? Just x. And here, what is the cube root of 8? 2, because 2 times 2 times 2 is 8. Okay? So fill in this guy, and then you can fill in the trinomial. So here's what you do. Whatever this is, you square this, and you put it there. So if I take x and square it, it becomes x squared. In the back, you take this number and square it. 2 squared, 4. How about in the middle? The definition said AB, where this is A and this is B. So you go x times 2, or 2 times x, which is just 2x, and that's your final answer. Again, what could you do on a test to check this? You could apply the distributive property. If you did all this in red, you'd get back the original. Okay, one more, or a couple more. Example B. Let's go with w to the 12 minus 125. Okay, this is a difference, and these are cubes. So let's set up our parentheses. Minus plus plus. Minus plus plus. So what is the cube root of W12? That would be W4, because W4 cubed would be W12, because it's W4 times W4 times W4. It'd be 4 plus 4 plus 4. What's the cube root of 125? That's just 5. Now to fill in the triple, you look at the double. So here for the first piece, you square whatever this is. W to the 4th times W to the 4th is W to the 8. In the back, you square 5 to get 25. In the middle, you go that times that, and that'll literally be 5W4. Final answer. Okay. One more of this kind, and then we'll do like, a finishing exercise. Example C, I believe. 64 h to the power of 30 minus 1. So this is a difference, and these guys are perfect. Technically, as if you guys look at this problem, this guy is technically a difference of squares, and it's also technically a difference of cubes. Wow, I didn't even see that until just now. This actually meets the criteria of both. So you could approach this problem with either of these two concepts, and technically it doesn't matter which one you use. You could hit it with difference of squares or difference of cubes. I'm just going to hit it with difference of cubes, and I'll just turn that in. But I would be willing to accept either of the answers, but don't do both because that's unnecessary. So let's treat this as a difference of cubes. Okay. So for a difference of cubes, set up a double and a triple with a minus plus plus. Now, cube root stuff. The cube root of 64 is 4. The cube root of h30 would be h10. So that's 4h10. The cube root of 1 is just 1. So always fill out your double, and then you can fill in your triple. So to find the first spot, you square whatever this object is. And if you square this term, you'll get 16h20. And in the back, you square whatever this is. If you square 1, it'll literally just be 1. And in the middle, you just go this times this. And that'll just be 4h10. Final answer. Okay. So now to finish off this video, just quickly, let's just focus on factorization with GCF only. Just the greatest common factor. For example, what if you have 3x squared minus 6x? You see that on a quiz, on a test, whatever. They ask you to factorize this. Look at these two terms and take out a common factor. What's common to both of these terms? How about 3x? I can take that out to the front. And if you take out 3x from 3x squared, you're left with x. If you factor out 3x from 6x, you're left with a 2, a negative 2, because you just keep the symbol. And that's it. There's nothing else you can do. The 3x stays, and nothing else happens in here. So that's your answer. Done. How about this one here? How about example B? How about we go with 2x squared minus 200? All right. Look for a common factor. I can take out a 2. Let's take out a 2. If I take out a 2, I'm left with x squared minus 100. Now, you don't want to stop there. The 2 is done. But why don't you look at the inside? Can we agree that this green component, that green stuff in its own right, is a difference of squares? So we can break that up into more pieces, right? So the 2 is done. But the stuff in here, that breaks up into 2 smaller pieces. That's a difference of squares. It becomes x plus 10 and then x minus 10. So always check for a GCF. Technically, you always want to check for a GCF right out the gate. And then whatever you're left with, decide if it's difference of squares, difference of cubes, trinomial, group factoring, etc. One last question before you go. What about something like this? What about x squared plus 9? What if you see this on your solo quiz on Monday? They ask you to factorize this. I know a really tempting answer. Why don't you go pencils down and just watch? It's really tempting to say this. X plus 3 times x plus 3. I know it's tempting, but this is incorrect. Let me prove it to you. X times x is x squared. X times 3 is 3x. The inside. 3 times x is 3x. 3 times 3 is positive 9. If you combine the middle pieces, that'll be x squared plus 6x plus 9. This is not the same as the original. It's not. So the original expression cannot be factorized, period. So you would just say something like fully factored. In other words, there's nothing else you can do. See that? So there's no such thing as a sum of squares. No, we cannot factorize a sum of squares like this guy. This is called a sum of squares because this is a sum and these are perfect squares. We cannot factorize a sum of squares using real numbers. You can factorize it using imaginary numbers, but we're not talking about that right now. So be prepared for a solo quiz on Monday that has everything that we just did in this video. If you have any questions, let me know. Have a great weekend, guys. See you on Monday. Bye.